Alright, today guys I wanted to talk about AOI logic implementation. And what I mean by that, I mean we've spent some other videos talking about how to take some of your logic expressions and truth tables and get them from circuits that are drawn out for us. Today we're going to look at, if we have the logic expression, how do we get the circuit back out from that. So just a quick reminder, your A is stands for AND gates, your O stands for OR gates, and your I stands for inverter gates. So just a quick reminder on that one. So I want to dive straight into an example here, just to kind of show how we might do this kind of thing. Grab a new sheet of paper here. So if we have the equation or logic expression, not A and B and not C and D plus or B, C, not D, on and then or A, not B. So that's going to be our logic expression. So we need to kind of look at this and decide how and what we need to get this out into a circuit. So the first thing is we've got this AND here. That's like a 4 input AND. So we can draw an AND gate here in the middle somewhere. We've got 4 inputs on that guy because we've got 4 inputs in this one. We've got another AND here, so we can draw one here, like that. This one's got 3 inputs, 2, 3. Then we've got one more, so we'll draw that guy down here. That one's just got the 2 inputs. These 3 ANDs all are ORed together, so we could draw one OR gate, kind of like that. Kind of bad at drawing them. And it's got 3 inputs. 1, 2, 3, just like that. Okay. Now each of these terms has its regular term and a not version of that term. So we're going to need 4 not gates. Got it. So what I want to do now is I've got all my stuff drawn. Want to just have a starting point for A, B, C, and D here. And then I'm going to draw all my attachments in red. So I'm going to have a nice node to start out each of these here. We know that eventually these will all go to their inverter gates, like that. And we know we all have to use them out in their standard form also, like that. Alright, so this first one is not A. So the first one we've got here is not A. Pretty simple. The next one is B. So we can draw that like that. And then not C. And then D. So that's that guy. Gives us that circuit. We get B, so we have to kind of branch off here. That guy. B, we've got C, and then not D, like that. And then this one is A, so this one's a little, I'm going to try not to get too messy here. Keep it as clean as we can. First one A there, and then not B. So we could do that going here. Try not to cross as many lines as possible. It does get a little messy sometimes, as you can see. Then all 3 of those AND gates have to be ORed together, so they should all go to my OR gate here, like that. And then once they go through the OR gate, we get F1. So that's kind of how you would go about doing that. Obviously, the more or the longer your logic expression, the more and more complicated this is going to be. But in this class, we don't typically have 4 input AND gates. For AND gates, we normally only have 2 inputs and sometimes 3 inputs. So if we're going to take this, we need to look at that and how we would do that as a 2 input or a 3 input guy. So we have to kind of just take a look at that again and see if we can do that instead. That way we can use it as an application for this class. So again, F1 is equal to not A and B and not C and D, or B and C and not D, or A and not B. Okay, so we got that again. We know that we have to have, just like the other one, A, B, C, and D. Still got the 4 inverters here. But this time what we're going to change is we're going to have to swap out that 4 input AND gate for 3 2 input AND gates. And the way we do that is we will have one 2 input guy here, another 2 input guy, and then a third one here that both of those kind of lead into. We can still have our 3, 1, 2, 3, and then we've got just another 2 down here like before, and then you've got your 3 input OR down here still. Okay, so we're going to take that, start getting our wires drawn in here. Again, I'm going to start out and just give a connection to all of my inverter gates, and then a connection that kind of goes out clean, like that. So the first one is not A and B. So if I go not A and B there, and then not C and D, like that. And then these 2 ANDs get AND there, and that kind of cleans that up for us. Next one, like before, is B, so we can add this node here, straight across, C, and not D, like that. So I'll connect. Last one, A, so we can come down this way, probably be the easiest, like that. Gets a little messy if you don't do it carefully. And then not B. So we're going to take this guy down here. Yep. So then this AND here goes to the OR, this AND goes to this OR, and then this AND goes to the OR. They all pop out. You get F2. So that is the way that you can take a logic expression. So this guy right here is a logic expression. We turned it back into the circuit, and we did it by a method called the sum of products. Sum of products, okay? Sometimes abbreviated as SOP. And the reason we call it sum of products is because we are adding together. So we are ORing some AND gates, okay? So we use an OR as our final gate, and we put it together with ANDs, so we have products, so we have multiplication, and we are summing them. So that's the sum of products for your logic circuit implementation.